Good afternoon, students. We are solving the problems of exercise 1.2. This is based on the topic inverse derivatives of inverse trigonometric functions. So we use the different rules as well as different formulae and properties of inverse trigonometric functions. Now we'll solve the examples of question number 8. Right? Question number 8, fifth example. Question number 8, first example. Y is inverse trigonometric function. Now how to find the derivative of this function y equal to sin inverse of 4 sin x plus 5 cos x upon root 41. What is the method? So this bracket either we will reduce to sine ratio or cosine ratio. So we'll take the help of addition formula for sine ratio. So how will you solve this example? See, you separate the numerator. Sin x coefficient is 4 upon root 41 and cos x coefficient is 5 upon root 41. These are two numbers and we will take these two numbers as sine or cosine ratios of some acute angle. Look at these numbers 4, 5, root 41. Actually this is the Pythagoras triplet. See triangle. 4 square it is 16, 5 square 25. So 4 square plus 5 square, 16 plus 25, 41 and square root of 41 is the diagonal of this right angle triangle. Now if I take 4 upon root 41, it will be some trigonometric ratio of acute angle, 5 upon root 41 trigonometric ratio of acute angle, and that acute angle will take as alpha. So 4 upon root 41, you take it as cos alpha. Yes. So we have to show alpha here. Adjacent side. Cos alpha in this right angle triangle, cos alpha. Adjacent side upon diagonal. And what is 5 upon root 41? It is sin alpha. Sin alpha, opposite side upon diagonal. Hypotenuse, opposite. Sin alpha equal to 5 upon root 41, opposite side upon hypotenuse. Now write this step also. Check what is cos square alpha plus sin square alpha. It is coming so identity is satisfied by alpha. Now change this to y. Bracket will be now 4 upon root 41 will take cos alpha. So first term is sin x into cos alpha plus 5 upon root 41 is sin alpha. So it is cos x into sin alpha. So what is bracket? Sin x cos alpha plus cos x sin alpha. Is it sin x plus alpha? Addition formula for sine ratio. So y is coming only x plus alpha. And what is alpha here? Constant angle, acute angle of right angle triangle. And x is variable. Differentiate y. What is derivative of x plus alpha? Alpha is constant and it is coming 1. So put this in square. Now try one more sum of the same question. Question 8. Right? Cosec inverse 10 divided by y equal to cosec inverse of 10 divided by 6 sin 2 raised to x minus 8 cos 2 raised to x. You cannot separate the numerator now because in the numerator you have only 10 and in the denominator there are 2 terms. So use property. You are writing cosec inverse as sin inverse. Cosec inverse x equal to sin inverse 1 by x. So your y will change as sin inverse of 6 sin of the angle for sine ratio, it is 2 raised to x variable. And this whole divided by 10. Separate numerator in the next step. One more step you write 6 by 10 3 upon 5, 8 by 10 4 upon 5. Now see the three numbers 3, 4, 5. It is again coming as Pythagoras triplet. And now take the coefficients of sine and cos in terms of sine and cos using the angle alpha. Now 3 upon 5 here it is coefficient of sine 2 raised to x. So I take 3 upon 5 as cos alpha. Is it the cosine ratio of angle alpha in right angle triangle whose hypotenuse is 5 and remaining two sides are 3 and 4. 4 upon 5 you can write as sin alpha. And now check what is cos square alpha plus sin square alpha. 9 upon 25 plus 16 upon 25. It is equal to 25 upon 25. It is 1. Now if you want to write alpha, you can write what is alpha by taking sin alpha upon cos alpha. 4 upon 5 divided by 3 upon 5. So your tan alpha, it is coming 4 divided by 3. Opposite side upon adjacent side. So what is alpha here? Tan inverse 4 by 3. This you can write. If you want to write what is alpha, you take tan alpha, it is sin alpha divided by cos alpha, which is 4 by 3, and that is why alpha is tan inverse of 4 by 3. And clearly, alpha, it is constant, it is tan inverse of 4 by 3. And that is why its derivative with respect to x, it is 0. So what is y? Sin inverse of 3 upon 5, we are taking cos alpha minus now bracket, it is addition formula for sine ratio. Sin 2 raised to x into cos alpha minus cos 2 raised to x into sin alpha. So I can take this as sin of 2 raised to x minus alpha. Now write y 2 raised to x minus alpha. Differentiate with respect to x. Derivative of alpha is 0. Derivative of 2 raised to x, 2 raised to x log. Okay. This is your answer of derivative dy by dx. Now you can solve the remaining examples of this exercise question number 8, because these are of the same type. Now go to question number 9 problems. Right? Question 9. First one. Question 9. Now here use substitution method for the variable. Use x you will substitute in terms of theta, so that formula you can use in the bracket. So if you substitute for x, you will get one formula, and bracket will reduce either in terms of sine or cosine. Clearly you can understand here 1 minus x square upon 1 plus x square. It is formula for cos 2 theta if you substitute x as tan theta. So x equal to put x equal to tan theta. What is theta then? Tan inverse x. Now change bracket. It is formula for cos 2 theta. Change cos to sine. So you are getting y as but write theta in terms of x. It is tan inverse x. Differentiate with respect to x. Derivative of pi by 2 0. Tan inverse x derivative. So final answer minus 2 divided by 1 plus x square. See, the problem is becoming very simple due to the substitution for x. When you substitute for x, the bracket will reduce to one of the formulae and will get very simple form of y, and it becomes easy to differentiate. Try now this sum. Bracket should be reduced in such a form that if we substitute for variable, it will reduce to the formula for cos 2 theta. Now see, in the numerator you have e raised to x minus e raised to minus x, denominator e raised to x plus e raised to minus x. So we have to make use of the trick here, so that we will get in the numerator 1 minus the variable term, and in the denominator 1 plus the variable term. So if I want, in place of e raised to x1, I should divide numerator and denominator by e raised to x, or I should multiply numerator and denominator by e raised to minus x. I am multiplying by e raised to minus x. Multiply each term by e raised to minus x. E raised to minus x into e raised to x1 minus e raised to minus x into e raised to minus x, e raised to minus x its square. Okay. Now I substitute for e raised to minus x. Put e raised to minus x as tan theta. Theta is tan inverse e raised to minus x. Change y. Cos inverse of bracket is cos 2 theta. So y is coming 2 theta. Write y in terms of theta, x. Differentiate. Two constant It is tan inverse u, not tan inverse x. 1 upon 1 plus u square into d by dx of u. Find this derivative. It is not e raised to x. It is e raised to minus x. Chain rule again. E raised to minus x its square. Minus x into 2. Minus 2x. E raised to minus x, it is multiplied by minus 1. The answer is coming minus of, which are the terms in numerator? 2 into e raised to minus x into minus 1 minus 2 e raised to minus x upon 1 plus e raised to minus 2x. This is dy by dt. Now see, I can simplify further. If I do not want the index of e as negative, I can change to positive index by multiplying numerator and denominator e raised to 2x. I am multiplying the numerator by e raised to 2x and denominator by e raised to 2x. If you keep up till this the answer, then also it is correct. But if you want to further simplify, you can simplify to get the positive index of e. Multiply each term by e raised to 2x in the denominator, e raised to 2x into 1, e raised to 2x plus e raised to 2x into e raised to minus 2x 1. The numerator minus 2 e raised to x. 2x minus x is x. The final answer minus 2 e raised to x upon 1 plus e raised to 2. Now next sum you try. Y equal to in this sum, if I substitute for x, there is no use because in the numerator and denominator we have x cube, not square. So to bring the square in the numerator and denominator, which trick you will use? So think over it. What should I do so that the proper substitution will bring the bracket in the proper formula? Trick is x cube. We are not changing x cube, keep in mind. We are writing x cube in this form. X raised to 3 by 2 its square. By law of indices, these two indices will multiply, 2 will cancel, and it is nothing but x cube. Denominator also same. Now substitute for x raised to 3 by 2. tan inverse x raised to 3 by 2. If you write this as sin theta, then theta will be sin inverse. If you write x raised to 3 by 2 as cot theta, it is cot inverse x raised to 3 by 2. But we are writing it is equal to tan theta, then only I can use the formula. Why we change as now sin inverse of bracket is of course cos 2 theta formula. To use the property change cos to sin, so y is coming right theta now. Y equal to pi by 2 minus 2 times tan inverse x raised to 3. Differentiate with respect to x dy by dx derivative of pi by 2 0 minus 2 into derivative of tan inverse x raised to 3 by 2. Keep in mind it is not tan inverse x, it is tan inverse u minus 2 as it is 1 upon 1 plus x raised to 3 by 2 x square. Why? Derivative of tan inverse u, it is 1 upon 1 plus u square into d by dx of u. Write this derivative now, x raised to 3 by 2. This is simple. It is equal to minus 2, 1 upon 1 plus x cube into 3 by 2 x raised to half 3 by 2 minus 1 n x raised to n x raised to n minus 1 3 by 2 minus 1 it is half and x raised to half is root x minus 2 divided by 2 minus 1 minus 3 root x upon 1 plus x cube. This is divided by dx. So one more you try. Y equal to cot inverse of 1 minus root x upon 1 plus root x. Now see why there is no sin inverse or cos inverse in the problem. It is cot inverse. So we have to use another trick here. Think over it. what shall I substitute for variable in the bracket so that proper formula I will get in the bracket. Now very simple. Cot inverse of 1 minus root x upon 1 plus root x. So what you are going to use here? Think over it, and we'll solve in the next lecture this example because I have very less time with me. I cannot complete this problem in this lecture. We'll continue this in the next lecture.